We're not going to be on our phones or anything, because that would be silly. It would be silly. Okay, so we're going to look at 0. Tan is what divided by what?
Y over X.
Y over X, correct? So at 0, what is our Y?
0.
0. What is our X?
1.
1. What does that equal?
0.
Good job. Plot it. So smart. Big brain. Okay. Then we're at 45. At 45 degrees, what's Y? Root 2 over 2. What's X? What does that equal?
1.
Big brains, right? So I'm going to make this 0.5 and I'm going to make this be 1. I'm going to make this be negative 0.5 and I'm going to make this be negative 1. So I'm at 45 and 1. Look at me. Rocket science right there. Okay, what about 90? What's Y?
0.
No.
X is 0. Y is 1.
Y is 1. X is 0. What does that mean?
It does not exist.
Undefined. What does that mean on a graph? Yeah. Good job. Vertical asymptote. Draw that baby. Vertical asymptotes make songs, it seems. I don't know where that happened. One person smiling, the rest of you are way too freaking serious. Huh? This is really a problem. I didn't foresee the ears being covered by these, and I can hear like nothing. I was doing the Little Mermaid. Good. You know, we could do like one of those like if you guess the song.
You have to do happy feet songs. You're a penguin. You have to do happy feet.
I don't know happy feet songs. Sad. Okay, 135. What's at 135? Oh, my finger. What's my Y at 135? They really do. Negative 1 over, oh, sorry, what is it? Negative root 2 over 2. Well, it's actually positive root 2 over 2 divided by negative root 2 over 2. So it's going to be negative 1. So this is 45. This is half of this is 135. So we're at negative 1. Boom. Okay. What about 180? We went over this yesterday with cotan instead of tan. What's my Y at 180? 0. What's my X? Negative 1. What's that going to be?
0.
Boom. Got it. Okay. 225. 225, what's my Y? Negative root 2 over 2. What's my X? Negative root 2 over 2. What is my answer?
1.
Positive 1. Why is it positive? Tan's what in quadrant 3? Positive. So, 225 and 1. $270. What's my Y at 270? Negative 1. What's my X? What happens? What do we get? A vertical asymptote. What's the distance between my vertical asymptotes?
90.
Why did that just switch to blue? Anyone? Anyone have a reason for that? My spin didn't do that. I don't know why.
180. You're right.
Yeah, so it's 180, correct? Which is what in radians? Pi, right? So this graph is actually repeating itself how many? Every 1 pi. The period of tan graphs is 1 pi. Remember the period of a sine and a cos graph is 2 pi, and the only thing that changed it was a horizontal stretch, right? If it made it bigger or shrunk it, correct? But tan graphs actually don't have a period of 2 pi or 360. They have a period of pi or 180. That's a big difference. Because if you look, the difference between each asymptote is 180. Correct? Okay. 360 or 315, let's do. So it's going to be y, which is negative root 2 over 2, divided by x, which is root 2 over 2. So I get negative 1, which makes sense because that's in the C of cast. So tan should be negative. So at 315, I have negative 1. And then at 360, my y is 0, my x is, and I'm back to 0. So if I go to sketch these, what ends up actually happening is you get something that does this. Now, could we put more points in here? 136, 137, 138, 139, 140. We could plot all the y's with different x's, correct? So we could do a more accurate graph here. But I'm just going to, ooh, that's supposed to be kind of straight. It's going to curve and then curve through here, is what you're going to end up getting. This should be somewhat straight. You're going to get a graph that looks like that. Now, if we want it more accurate, we'd have to pick more x values in between and correlate more y values, correct? Which we could do. We have 30s, we have 60s, we have more points we could do. We just have to do y divided by x to get our point, y divided by x, right? Or we could go tan of, I'll show you. Go tan in your calculator, go tan of 300.
Negative 1.732.
Negative 300 is negative 1.732. So negative 300 would fall in here, correct? So it would be somewhere down here. So your graph is going like this, then through this, and then it would stop there, right? But it's curving like this. So same thing's happening here. You're going to end up at negative 90. What's going to happen? Because this just repeats itself. It's periodic. What's going to happen at negative 90? If at 90 I have an asymptote, at negative 90 I'm going to have an asymptote. Why? It's 180 away. And this thing repeats itself every 180. Correct? So if at 45 I have 1, then here I'm going to have 1. If at 135 I have negative 1, then at 45 I'm going to have negative 1 because it's 180 away. Right? This thing just repeats itself over and over and over. So if this one's at this one's going to be at 0, this one's going to be at negative 1, then I'm going to get another asymptote. Because negative 90 to negative 270 is 180 away. Plus, you just get the coterminals. It would just keep landing on those same spots on your unit circle, right? Over and over and over. So you're going to get it. Most accurate drawing ever? No, I don't have a whole bunch of things on it, but. It's just going to keep going. What do you think negative tan x is going to do?
Opposite.
Yeah. It's going to cause it to reflect in the x-axis because negative would be in front, correct? So a negative, don't draw this because it's not on here, I'm just showing you. A negative tan x would actually do this. Because this would pop up there and then this half would pop down there, right? So you just get a negative slope if it was a negative tan x. So go to your calculator and in your y equals type tan x. You're going to do that. You're going to type tan x. Then you're going to go to your window and you're going to make your window match my window. And what's my window up here, or the one in front of your face? Negative 360 to positive 360 for your x. And what's it going up by? What's your x scale? What's the first pick? 45, right? And then your y minimum is going to be negative 1. Your y maximum is going to be 1. And what am I going up by? 0.25. Correct? Now, before you press graph, what should you always check? The mode. Or before you go to press tan, you should slap your hand and be like, what mode do I need to be in? Well, what's the x-axis of this graph in? Degrees. So what mode do I need to be in? degrees. I also just made a degree window, didn't I? So if I go put it in radians and I do a degree window, is that going to work out for me really well? No. Yeah.
What was that other like trick on the calculator where I forget what it was? Like if you didn't know, you can also like
Zoom trig. So once you press the mode, you can go zoom and then trig, which is 7. If you're just completely stuck. So we want to see if our graph is accurate. Does our graph on our calculator look exactly like the graph in front of our faces? Obviously not as perfect because I didn't plan to plot like every point known to man. Does it look similar? Yes. Now, if I wanted more accurate points, could I not go to my table of values and pull more off of there? They're going to give you one every degree. So you can get super, super crazily along, right? Okay. That makes sense? Good. Because we're going to answer some questions. And then down here, for homework, you're going to redraw it, but it's in what? The axis. In radians. So it's nothing crazy. It's just in radians. Okay, but that's going to be for homework, not right now. What's the period of this graph? What's the period of this graph? Pi.
180
Well, in this case, it's actually 180 because the x-axis is in degrees. So you know the formula for the other ones to find b if I had the period, I would go 360 divided by p to get the b value, correct? For these ones, you're going to do 180 divided by b because they repeat themselves every 180, right? So if they actually asked for the b value on a tan equation and they gave you the period, you would actually do 180 divided by b, not 360 or 2 pi, right? Okay, what's the amplitude of this one? Is there an amplitude? Amplitude is like, it's from the min to the max, it's this much, divided by 2, correct? Does this one have that? No. Your amplitude would just be infinite. I could never find it. Where do the x-intercepts of this one happen at? What's the first positive one? First one's at 0. Then my next one's at 180. I should have degrees symbol, sorry. 0 degrees, 180 degrees, 360 degrees, etc., right? And then negatives of all those, right? It would be negative 180 and then negative 360, which makes sense because if I start at 0, this baby's repeating itself every 180, right? Correct? So 0, my next x-intercept would be 180. Yeah. Yeah. Then 360 and then etc. Right? Because it repeats itself every 180. So, how do we write x-intercepts if they keep going on for life? We can use general term. Do you remember how to do that? General term. So your x-intercepts, you would write the very first one. So x equals, what's my very first one? 0 degrees, correct? And we're going to talk about these a lot more also in the next part too, in chapter 6. But we're going to start off with 0, and then how often do they happen? Plus 180 degrees, n, you should use an n, yeah, that's what I use, n. And then what do you follow behind with? N is an element of the integers. Now why is it of the integers? Right. So if I go n is an element of the integers behind this, I could plug in the first integer, the neutral integer, which would be 0, correct? If I plugged a 0 in for n, I get 180 times 0, it would be 0. Boom, I'd have 0 as my first answer, correct? If I plug the next integer in, 1, I'd go 180 times 1, which is 180, plus 1, so I get 180. Oh, there's my next one. So when I plugged in n equals 0, I got this one. When I plugged in n equals 1, I got that one. When I plug in n equals 2, I'd go 180 times 2, which is 360 plus 0 is 360. Oh, n equals 2 gets me 360. N equals negative 1 would get me negative 180. N equals negative 2 would get me negative 360. So that's why we use integers, because when you plug that in, you're going to get every single answer for life, right? We're not going to go just dot, 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 dot in other directions. We're going to actually give a general solution. Do I need to write the 0? No. When your principal angle, when your first angle is 0, that's the only time you don't have to write your first angle. So in reality, this isn't wrong, and if you stated it that way, you would not be wrong, but the multiple choice answer won't be that. It would be just 180 degrees n, NEI. Okay? What's my domain of this baby? Domain of sines and cosines is just XER. They just flap out. Works really well with my wings. Or fins, whatever these are. I don't even know what these are. But the domain of this one, do they exist everywhere? No. The moment there are asymptotes, you just actually say where those are, and you say, not happening. That's what you say. You're like, nope, not there. Not happening there. Okay? Well, how do we say not happening there? We say x can't equal there. Correct? So let's see. Where do they happen? Where do the asymptotes happen on this baby? Where does the first one start? 90. Okay, let's talk about the first one starting. So we know x can't equal 90. And then what's my next one? 270. And then etc. Correct? Did we just do a general solution that encompassed every answer one way or every answer the other way? Right? With x-intercepts, we did a general solution. We're going to do the same thing here. Where's my first one? My first one is x can't equal 90. Remember when we're putting dots in one direction and technically dots in the other direction? We don't write it that way, correct? When we go, it's going to carry on this way, it's going to carry on this way. The only way we can write that is by doing a general solution. So my first one is 90 plus, when's my next one going to happen at? 270. How much is that? Plus 180 degrees. N is an element of the integers. Does that cover all of them? Does that cover 90, then 270, then this one, then 90 minus 180, so negative 90, negative 270. Is that covering everything? Yep. Good. And I just go like this. X such that. Toss some brackets around it. I have my domain. So when there's asymptotes, you literally give your domain by x can't equal these spots. And then you should follow behind with, erase. X and element of the reals. Why should I follow behind with x and element of the reals? X doesn't exist at all these spots, right? That's what I stated. And then I have to follow behind with an x and element of the reals. That means it's everywhere else, right? Everywhere else besides those points. What's the range for this one? Sorry, I can't hear you because I literally can't hear.
Infinite?
Yes, infinite. So we would go y such that y is an element of the reals, because it just keeps going on forever. What are the equations of my asymptotes? Yes?
X equals 90, 270,
Right? Or I could write it as?
plus 40.
So it's just the x equals instead of doesn't equal that you would have in your domain, right? Because it's the same thing. So it'd be 90, 270, actually negative 90, negative 270, But we would rather write that as x equals 90 degrees plus 180 degrees n, NEI. Okay? Then the graph underneath is going to be part of your homework to do. You're going to redraw the trig graph, or the tan graph without looking. Now we're going to flip over. We have one last little thing. It's a very little lesson. So, you can use the actual graph to do this, or we can just use our knowledge base. This is nothing new to you. This is literally like I give you tan of an angle, you give me an answer. That's it. This unit lesson is actually really tiny. So what's tan at 2 pi? 0 over 1. And because we've learned how to use our graph, we could just look at it and say it's 0, right? So off our unit circle, we know it's 0 over 1, which is 0. Off our graph, we know it's 0. They correlate, right? Our graph is just our unit circle. We know that. That's how we learned how to draw our sine and cosine graphs, is from our unit circle. It's just a way to represent the unit circle over an x value time, right? Like to make it just drawn out. This one's like this. So tan at 3 pi over 2
Doesn't exist.
does not exist. Now, 3 pi over 2 doesn't exist because what does that create on an actual graph? Does not exist, creates a vertical asymptote. You're completely correct. Tan of pi over 4. It's 1 because off of that it's 1, but also because on your unit circle it'd be root 2 over 2, which is your y, divided by root 2 over 2, which is 1. Also, pi over 4 is in quadrant 1. Because in quadrant 1, everything is positive in quadrant 1, right? And at 45s for tans, you're going to get positive or negative 1s. You guys all know that. Tan negative pi over 4. That would just flop down. So it's in the same spot as 7 pi over 4, right? And at 7 pi over 4, it would be your y is negative, so root 2 over 2 divided by root 2 over 2. Negative root 2 over 2 divided by root 2 over 2, which is negative 1. Also in quadrant 4, you know tan's negative, right? We know all 45s are 1. So in quadrant 4, you're going to get negative 1. In quadrant 3, you're going to get positive 1. In quadrant 2, you're going to get negative 1. And in quadrant 1, you're going to get positive 1 because of cast, right? So you know that as well. You do example 3. These 3. We have 9 pi over 4. It's too big, so we're going to subtract 2 pi, which is over 1. So we're going to multiply this one by 4. So we're going to get 9 pi over 4 minus 8 pi over 4, which is just pi over 4. So this is the same as tan of pi over 4, which is, what'd you get? 1. Okay? You can also check these. You can put your calculator in radian mode and type tan 9 pi over 4 and you should get 1. Should you not?
Yeah.
You can check them in your calculator, radian mode, tan 9 pi over 4 and get 1. Okay? Now we have negative 13 pi over 4. We're going to add 2 pi. Shh. So adding 2 pi is like adding 8 pi over 4. So we're going to get negative 13 pi over 4 plus 8 pi over 4. Which results in negative 5 pi over 4, which I have to add another 8 pi over 4, because that's 2 pi, and I get 3 pi over 4. I keep going, add 2 pi, add 2 pi, add 2 pi, right? And I get 3 pi over 4. Could you convert negative 3 pi over 4 to degrees and then add 360, add 360? If you really want to, you could do that too. There's so many different ways you could go about this. Okay? So I'm just adding 2 pi to negative 13 pi over 4, which gets me 8 pi over 4. Keep the denominators. I get negative 5 pi over 4, still not on my unit circle, so I add 2 pi. But at this point, I know 2 pi is the same as 8 pi over 4, so I add that, and I get 3 pi over 4. So now I'm going to do tan of 3 pi over 4, which is equal to negative 1, because it's in quadrant 2. And then we have tan of negative 17 pi over 4. This is getting bigger. Negative 17 pi over 4. If I add 2 pi, it's the same as adding 8 pi over 4, just because these are all over 4s, right? Which is going to get me negative 9 pi over 4. Then once again, I have to add 8 pi over 4, which is 2 pi, which gets me negative pi over 4. And then I add 8 pi over 4 again, which gets me 7 pi over 4, which is in quadrant 4. So what's it going to be? Negative 1. Because closest, or tan's negative there. So it's just getting the coterminals, right? Adding, 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 adding. So what's a general solution to tan theta equals 0? Where does tan theta equal 0 at? Do you guys know? Theta equals 0, pi, 2 pi, 3 pi. We just keep going, correct? Do we agree? So we're practicing general solutions again. So we know that tan theta equals 0 at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. But I'm doing dot, 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 dots. Instead of doing dot, 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 dots, we don't do that in grade 12. We write general solutions. So how do we write a general solution? We just do theta equals our first positive. What's our first positive at? 0. Then I add how much it takes to get to every next one. How much does it take me to get to the next one? Pi and the next one. Pi and the next one. Pi. It's just pi each time, right? So instead of saying pi, 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 I'm going to go pi n. N is an element of the integers. Now what did I tell you about the 0? They just don't write it, because 0 plus anything doesn't change anything, correct? So when it's 0 plus something, we can just go pi n, nei. And we don't need the plus sign in front because there's nothing being added to it, right? For b, it's tan theta equals 1. Tan theta equals 1. Okay? Where does tan theta equal positive 1?
45 degrees.
At 45 degrees? We'll do this one in degrees, sure. It didn't no, it doesn't specify, so we'll do 1 in radians and 1 in degrees. So we'll go 45 degrees. But where's our next one? At 225, right? And why is that? Because tan's positive in quadrant 1 and quadrant 3. It's also because root 2 over 2 divided by root 2 over 2 in quadrant 1 is 1. And then negative root 2 over 2 divided by negative root 2 over 2 in quadrant 3 is 1. That's the reason why they're 1s, right? Positive 1s. So it's in quadrant 1, which is 45, and then quadrant 3, which is 225. And then I could just do the coterminals of those. Keep going and going and going, right? Dot, 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 dot. So the reason why tan general solutions are so nice is because tans are always across from each other, right? Because all is in quadrant 1, and quadrant 3 is where your t's are going to be, right? So tans are positive completely across from each other every 180. That's why they repeat themselves every 180. And tans are negative across from each other in 2 and 4, right? Every 180, every 180. So they're nice to be able to make general solutions of because it's every 180 that they're happening. So what's my first positive? 45 plus 180 degrees. And I have to always put up n, and then n is an element of the integers always, because that'll give me 0, 1, 2, -1, -2, etc. Make sense? Okay. This lesson is like a very small portion of your curriculum, but we still show it just so you know, just if they ask about range of degrees. We don't have to like make equations of tangents and stuff like that we do in science and cosines, but mainly knowing your general solutions and such, vectors, intercepts, and all that. So this is your homework. So you're going to complete on page 263, you're doing number 2, and then the page right before this, there was that tan graph open spot that was in radian measure. I want you to draw it. Okay? So the only homework you're going to have to show her, though, is number 2. All right? But I want you to complete this one. So you've drawn one on your own.
What?